Hello, good day everyone. I'm Sir Sandro, and in this video, I'm going to talk about absolute value inequality. This is adapted from the Philippine Science High School System Learning Guides. Our target for this video is to solve absolute value inequalities in one variable and represent the solution set graphically. Well, the absolute value equation and absolute value inequality look very similar. Okay, they look very similar. However, absolute value equations have equal signs and absolute value inequalities have inequality signs. So, of course, any value that makes an inequality true is called a solution. So let's start with this illustration. Let's start with this absolute value of x is less than 2. And we are going to find any x values that would make our absolute value inequality true or false. All right. So let's start with this one. I think we already discussed this last meeting, but I just want to reiterate this one. If, for example, our inequality is absolute value of x is less than 2, say x is equal to 5, then we say that the absolute value of 5 is less than 2. Is that true or false? That is false, right? It means 5 is not part of our solution set. Another example, -1. If x is equal to -1, we can substitute the -1 to x here. That's why the absolute value of -1 is less than 2. Is that true or false? Absolute value of -1 is 1. 1 is less than 2. Is that true or false? That is true. That's why we say that -1 is a solution of that absolute value inequality. Next, how about if 1? If we substitute 1 to the absolute value inequality, we have absolute value of 1 is less than 2. Is that true or false? That is true. So therefore, 1 is also a solution. Next, -3. If we substitute -3 to our absolute value inequality, we have the absolute value of -3 is less than 2. Absolute value of -3 is 3. Is that less than 2? That is false, right? And then 0. Absolute value of 0 is less than 2. 0 is less than 2. That is true. So therefore, these are concrete examples, no? Concrete examples of solutions, no? Solutions of our absolute value inequality. Like last meeting, you were able to discover that if we were to graph, no? If we were to graph the solutions of the absolute value of x is less than 2, we discovered that all numbers, no? All numbers between -2 and 2 are solutions. So we can have, for example, the 0, the 1, the -1. We can also have the 1.5 or 0.5 or -0.5, etc. As long as it's between -2 and 2. All right. So let's also review this one, the properties of absolute value. We have here, if absolute value of x is less than a, then x is greater than -a, but less than a. And we can write that using this. We can illustrate that through this graph. Okay, that's intersection, right? It's an intersection. So that's between -a and a. So everything that is between -a and a are solutions. That's property number 1. Property number 2 is kind of similar to property number 1. But this one is less than or equal to a. So if absolute value of x is less than or equal to a, then x is greater than or equal to -a, but less than or equal to a. So if number 1 is hollow, no? In this case, number 2, property number 2 is solid. Okay, it's shaded here. So from -a to a. That's the solution set. Okay, and of course, number 3, we have here a union. if absolute value of x is greater than a, then x is less than negative a or x is greater than a. So we can illustrate that through this one. Negative a, x is less than negative a. We can illustrate that through this graph. Since this is an OR union, so we are going to combine. X is greater than a, this one. Ayan. But of course, since it's greater than, this is hollow. Okay, hollow. It means negative a and a are not included in the solution set. And number 4, we have here, if absolute value of x is greater than or equal to a, then x is less than or equal to negative a, or x is greater than or equal to a. So in this case, the negative a and a are included in the solution set. Okay, so though medyo hapos mo lang, no? Medyo hapos mo lang ang aton nga mga properties. And let's apply them through these examples. All right. Let's have example number 1. Example number 1. So for this particular given or example, you are going to solve the absolute value inequality and express the solution in interval notation and graph. Okay? Interval notation and graph. So first one is the absolute value of x plus 4 is greater than 5. Okay? The absolute value of x plus 4 is greater than 5. So the first thing that we're going to do is to identify if this is a union or intersection. Since this is greater than, no, it means this is a union. And I think last meeting, I shared with you the mnemonic that I'm using in order for me to remember if the particular absolute value inequality is an intersection or a union. So in this case, we're going to use great 4. Okay? Great 4. Greater than or equal to, it means it's or. Means union. Okay? This is a union. So therefore, since we already identify it as a union, we are going to set up our inequality. So the first one is x plus 4 is greater than 5. Again, this one, this case one, I just dropped the absolute value sign and copied everything. So in this case, x plus 4 is greater than 5, or since that's a union, we have x plus 4. Okay, take note. We are going to change the sign. Since this is greater than, we're going to put less than here. And we're going to multiply negative 1 to 5. So in this case, we have it's less than negative 5. Again, there are 2 changes. First is the reverse of the original absolute value symbol. Since this is greater than, the case 2 would be less than, no? Less than. And then we're going to multiply negative to 5. So negative times 5 is negative 5. And then just solve. In this case, we're going to apply the properties or the properties of absolute value inequality or absolute or linear inequality. Okay? So in this case, we have to minus 4 here, minus 4, subtraction property of inequality. We have x is greater than 5 minus 4 is 1. Okay? So x is greater than 1. Then or, we have to minus 4 here, minus 4. X is less than negative 4 plus negative 4, negative 5 rather, plus negative 4 is negative 9. Okay? So this is our solutions, no? Our solutions for this particular absolute value inequality. Now, we are going to write it in interval notation. Okay? Interval interval notation. So in this case, the interval notation, since this is a union, then let's write them individually first, okay? X is greater than 1. How are we going to write that in interval notation? X is greater than 1. We can, since it's greater than 1, so it's approaching, no, sorry. From 1 up to positive infinity, right? And then let's enclose that with parentheses. And since it's greater than 1, therefore, we're also going to enclose 1 by a parenthesis. It means 1 is not included in the solution set. And this is OR, so union. We're going to use this U as a symbol of union. And X is less than -9. No? X is less than -9. Therefore, this is from -9 up to -infinity. Do you have any question so far for the interval notation? None? Then let's proceed to graph. Let's graph this solution set. Graph. If we have here, so let's try to graph this. X is greater than 1. Say, for example, let's label this as -9, and then this one is 1. Okay, 1. -9 and 1. We can graph X is greater than 1. Greater than 1. So dito siya makadto to the right, since X is greater than 1. And X is less than -9. Makadto to siya sa -infinity. And yeah, that's the graph of our absolute value inequality. Okay? Simple lang, right? If you know how to identify if it's a union or intersection, then you just set up your absolute value inequality on case 1, case 2. All right. So after this, do we have any questions? None? Okay, let's proceed to the next example. Example number 2. How about if you have this one? Number 2. 2 times the absolute value of x minus 7 minus 9 is less than or equal to 5. Okay, again, 2 times the absolute value of x minus 7 minus 9 is less than or equal to 5. So the first thing that we're going to do is to isolate the absolute value. So in this case, we see that there's 2 here and there's -9. And we need to deal with these first. We have to remove them, no? Para ma-isolate natin ang absolute value, which is the absolute value of x minus 7. So the first thing that we're going to do, what do you think? Is the first thing that we're going to do. We have to add 9. That's right. We're going to add 9 on both sides. Add 9. And then we have, just copy this, 2 times the absolute value of x minus 7 is less than or equal to 9 plus 5, that is 14. Okay, this will become 0. And then, what's the next step? Na-transfer ta na, no? Na-transpose ta na si -9, pakadto sa right. We add 9 on both sides. What's next? We have to get rid of this 2. What are we going to do? We have to apply the division property of inequality. Fantastic. So we have to divide everything by 2. Divide everything by 2. So therefore, we have the absolute value of x minus 7, this will cancel, is less than or equal to 14 divided by 2, that is 7. So since this is less than or equal to, so we use this mnemonic aid, less than. Kaginaya sa greater, gadil naman to saya sa greater than or equal to, no? Greater than or equal to. In this case, we can use this mnemonic para ma-remember natin ang less than. Basta less than or equal to, then less than, and we know that and is an intersection. Intersection. Okay? So in this case, we are going to set up our inequality. First thing that we're going to do is to copy everything, drop the absolute value, okay, and then copy everything. So we have x minus 7 is less than or equal to 7, okay? X minus 7 is less than or equal to 7. We get the reverse, no, of this, less than or equal to. So we have greater than or equal to. And then we're going to multiply this, 7 by a negative. So we have negative 7. Is that okay? Again, I just copied everything. After dropping the absolute value sign. And then since this is less than or equal to, then gin-reverse ko sa less than or equal to, naging greater than or equal to, and then times ako sa negative sa 7. So we read this as x minus 7 is greater than or equal to negative 7, but less than or equal to 7. And then just solve for the value of x. That's the first step. We're going to what? Going to add 7 in the center, right, and left. So we have x is greater than or equal to negative 7 plus 7, that's 0, but less than or equal to 7 plus 7, 14. Again, our absolute value or our solution is x greater than or equal to 0, but less than or equal to 14. After solving, we can graph it first. Let's graph. So since this is an intersection, this is an intersection, we can have 0, 0, and then we have 14 here. X is greater than or equal to 0, but less than or equal to 14. So this is just between, between 0 and 14. But 0 and 14 are included. So we have this. It's our solution set. Okay? Are we okay with that? Our graph, and of course, our IN or interval notation is just 0, 14, and we're going to enclose it with brackets because 0 and 14 are included in the solution set. Okay lang? All right, we're done with example number 2. Let's try the third example. Okay, let's try the third example. Still the same. We are going to solve. We are going to solve the absolute value inequality. We're going to express our answer in interval notation and graph it. All right. Number 3 is the absolute value of 8x plus 3. 8x plus 3 plus 6 is less than 1. Again, the absolute value of 8x plus 3 plus 6 is less than 1. So the first thing that we're going to do is to isolate the absolute value. So we're going to minus 6. The absolute value of 8x plus 3 is less than 1 minus 6. That's negative 5. All right. And we have to remember the property, one of the properties of absolute value, which is what? Can you still recall? That an absolute value, ano ni ganing iyang value? It is always positive, right? Correct. It's always positive. So in this case, class, before you do your greater or less than, just use your common sense first. The absolute value of 8x plus 4 is less than negative 5. Is that even possible? Is that even possible? So we know that the answer of this is positive, right? Positive is less than negative. Yeah, negative. Negative 5 in particular. That is a false statement. A positive will never be less than to a negative number. So in this case, class, we have a contradiction. It means this statement is never true. So we say we don't have to solve. We can conclude now that therefore this is an empty set, or there is no solution. There is no value of x. There is no value of x. Any real number, no, that would satisfy our absolute value inequality. Okay? Empty set kita. So, hindi ta naman mag-graph kay wala man kita may i-graph. Empty siya mo, right? And then, ang aton nga IN, di man kita ka-interval notation kay empty set siya. So, let's proceed to the fourth example. The fourth example, we have the absolute value of 5x plus 2 plus 9 is greater than 2. So in this case, we are going to isolate the absolute value by subtracting 9, no? Subtracting 9 on both sides. Minus 9 kita, minus 9. The absolute value of 5x plus 2 is greater than 2 minus 9, that's negative 7. Now stop and analyze. I want you to think about it. We know that this is always positive. Positive is greater than negative 7. Is that true or false? This is always a true statement. This is always true. Positive will always be greater than any negative number, including negative 7. So in this case, right, we say that the statement is always true. Okay, so therefore, if we are going to write that in IN, we say that the solution set is all real number. And of course, if we're going to graph all real numbers, so we have here. Yeah. Any question so far? Okay, that's the end of our 7.2.1. I'm going to see you in the next video. Bye-bye.